So Bobby, we have done many transforms, Laplace transforms.
Yeah.
So I think when we solved some of them, we went back and showed
Correct,
students that
correct,
we have done this.
correct.
Maybe we should have one place.
Yeah.
Where
Otherwise,
we,
I'll be moving around and then
correct.
hunting for
So
the transform.
in the future, when we do an example, we'll
Correct.
come back to this page,
And
look
get
at it, and then go back. Right? We'll do it like that.
So we will list down whatever we have done so far.
Correct.
Good idea. So we'll have the time domain signal f of t, which is also Laplace inverse of f of s.
F of s. Correct.
Okay, and then we have f of s.
F of s, which is Laplace transform of f of t.
Okay, I think if I draw a straight line, it may not come as a straight line, so I'll skip that. So where did we start? U of t, I think.
U of t was the first one we did.
So U of t we did. Then we did T U of t.
T U of t. Correct. Ramp.
Yeah.
Correct. Then we did, I think, delay e power minus at.
Yeah.
Correct.
E power minus at U of t.
Correct. Okay. So maybe let's write down the Laplace transform of these. So I remember U of t, the DC value for positive 1 over s, no?
This was 1 by s.
Correct. And
this
t
was 1
by s squared. Is that right?
Yeah.
Okay, I understand now. So now I'm getting some idea. We saw that if you integrate something, we saw in the last class, the integral gives you 1 by s f of s.
Correct.
So the integral of a step is a ramp.
Integral of a step is a ramp.
Is a ramp. So you should just be able to multiply 1 over s times 1 divided by s. You will get this.
Okay.
I can see if we knew that property earlier, we could have done it easily.
But one has to think like your thought also.
Correct. So there are many ways of combining properties, and it's right to arrive at the same answer.
True. And this is
e power. It was 1 by 1 plus s plus a.
1 by s plus a.
Yes.
So did we do t e power minus at? No.
No, we have not done that.
Oh. What it will be? Oh, we have to maybe try.
This is hard. No, this is a much more complicated function.
Not very straightforward.
Let us do it on the next page.
I'll take a fresh page and try.
Yes.
So f of t is t e power minus at u of t. F of s 0 minus 2 infinity t e power minus at e power minus st dt. Okay, I'll rearrange a little bit. 0 minus infinity t e power minus s plus a
times t dt. Okay.
We have to use uv again.
Yes. You can never get away from that so easily, no?
uv seems to be.
Yes.
Yeah. So this is our dv. Huh?
dv and t is u.
So if this is dv, v is e power minus s plus a t y minus s plus a.
Yes.
Okay. And This is du.
U. T is U.
Okay.
Right?
So that means du is
Is 1.
1.
Correct, no? So U dV, integral U dV,
Correct.
which will be uv minus integral
Integral
v
VdU.
du.
Anyway, I'll write it down. uv minus integral v du. So u is t,
Yes.
v is this one, e power minus s plus a into t divided by minus s plus a limit 0,
Zero
minus
minus
to
to infinity.
infinity v minus integral 0 minus to infinity v du. V is here, e power minus s plus a y minus s plus a p du is 1 dt.
dt. Correct. So I think we should write du is 1 dt technically.
Correct.
Yes.
Oh, what is this giving? So we can give maybe apply limit here, no?
Yes.
Infinity
Means
that
e power
will
minus s plus a t will go to 0.
0.
Correct. And that it goes to 0 faster than, if you need to apply limits, right? It goes to 0 faster than t itself.
Correct.
So
And here t equal to 0.
t is
so
equal to 0. So this will be, yeah.
that is gone. So this plus, so
Correct.
I can,
So
that
1
will
by
become
1.
plus
Yeah, 1 by s plus a.
1 by s plus a integral.
Oh, maybe now we can separate it and write it. We can write it as e power minus at
Yeah.
into e power.
Do we need that?
Well,
That may help. no?
that may help.
Okay. So e power
Minus at into e power minus st dt. Because we just wrote down the expression in the previous page for this.
okay.
This is just the Laplace transform of e power minus at.
Okay. So that will be
We derived that it is 1 by s plus a.
in the previous page.
In the
it is
previous page we have written. Yeah, correct. E power minus at u of t
Oh,
is
this
1
one.
by s plus a.
there. Oh, super. You have optimized that. Oh, so that means it will be 1 by
Correct.
s plus a whole square.
Yes.
Oh. So when we had t, it was 1 by t u of t, it was 1 by s square. Correct.
Correct. So this is 1 by s plus a the whole square.
I can smell something, but not very clear about it.
Okay. Okay.
Correct. Now there is some
Correct.
logic here.
There's some logic there. I do see it. Yes.
1 by s plus a whole square.
Correct. I see what you're saying. Right?
If it takes some derivative of something, it's
Correct. So we need to look at that also. That property.
What is that property?
I think we had said that
Or from here,
maybe
whether
we
we
can
will
see
be
if
able
we
to
can-
go?
Okay.
Will it
Let's
be,
try that. Let's try that.
I'll just copy that.
Sure. By the way, I just wanted to point out. So we had f of t as e power minus t u of t. I think we didn't write it explicitly here,
But u of t
but
is
everybody understands that. That's why we have e power minus at u of t times this.
there. Yeah.
I think because we are talking about t greater than 0,
Correct.
we have not included t equal to 0. But technically, I think mathematically the property is e power minus at u of t has 1 by s plus a. I think just students should understand that. We have not written it for negative t's.
Yeah. limit is also,
Exactly, because we have done the limit is that way, so it is, yeah.
yes. So you were saying we can try something. What
We
is
can
that?
try something. So what I remember is, long ago, I think we did some, okay, so let us see, maybe we can write t e power minus,
Oh, you want to generalize this?
I
huh?
want to generalize this in
Okay.
some way, so I'm
So
trying to
instead
see.
of e power at t, f of t.
Yes,
Oh, that may be more useful.
yes. So then we can just do it for any function.
If we get something useful.
If we get something useful. Let's see if we get it.
So what shall we do?
Okay.
T e power minus st.
Correct. F of t is general function, we can't do anything.
Correct.
Maybe, oh, okay, how about this?
Hmm.
T e power minus st,
Hmm.
can we write it as a derivative of e power minus st in some way? Let's
So
see.
f of t we will retain.
Yes.
T e power
Minus
st.
Mm,
You want to derivative of something should be this.
should be this. Correct.
So then d by dt of
D by dt will not give us. D by dt will just give, yes, we need d by ds. Correct.
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 D by ds
Of e power minus st will give us minus t e power minus st.
So that means I should have a minus symbol also.
Correct. Correct.
Oh.
This is correct. Minus d by ds of e power minus st will be t e power minus st.
So let me plug in that here.
Yes. Okay.
So minus d by ds of e power minus st
Correct.
dt.
dt. Okay. Does this help us in any way?
Now you want to differentiate for or integrate first and differentiate later.
We looked at that property earlier,
Yeah.
right? So you're integrating with respect to time variable, differentiating with respect to s,
Okay.
and the function is function of both f of t and e power minus st. So what we'll do, we can interchange the two.
Okay. Let me try d by ds of integral 0 minus 2 infinity f of t e power minus st dt.
This we know.
Oh, you are very smart.
This is f of s, right? Capital F of s.
So it's
Okay.
it's f of s.
Perfect.
So this is minus t by ds of f of s.
F of s. And now we need to make sure that this is correct by setting f of t to e power minus at.
So if we do that, will I get the
Will I get 1
previous
by s plus
answer?
a? That also we should check.
Okay.
So let us put f of t equal to e power minus at.
So I will just write down here.
Correct. Yes.
What we had was, I mean, you wanted to have f of t equal to e power minus at.
Because we were trying to find the Laplace transform of t e power minus at.
Then we will write t e power
t f of t will be t e power minus at.
Correct.
We'll write it like that.
Correct.
Correct.
Okay. So for this,
so the Laplace transform of that will be minus d by ds of t f of t, yeah, t e power minus at. Yes.
minus d by
ds
ds of f of
correct. f of t is e power minus at.
yeah.
So capital F of s is 1 by 1 plus a. Sorry, 1 by s plus a.
1 by s plus a.
Correct.
Okay, so now this will be minus 1 by s square. There is a minus
Minus
symbol here.
sign, so it will be 1 by s plus a the whole
S
square.
plus a the whole square.
Okay. Luckily, it is giving us the same answer.
I think this color is a bit difficult to read. Anyway, 1 by
Yes.
s plus a whole square.
Correct.
Did we get that? Oh,
That's
we
what we
got
got.
it. Okay, okay. So we'll come. Oh, We have already filled the table.
We have already filled
Okay.
in because we did using the UV method.
Correct. Now maybe we should write, I think we have done for sine wave also.
Correct. Sine and cos we have done. Correct.
Sine omega t.
Yes. Sine omega t u of t, I think is
U
what we
of t.
did.
This was omega.
Omega by s squared plus omega squared.
Similarly, cos omega t.
Correct. Now we can start applying the rule. I think I see a pattern.
What is that?
I'm wondering, because if you differentiate sine, you get cos. If you integrate cos, you get. So now that we know these tricks, we have already derived it. We know the expression. Maybe the students can check now that we are giving them ideas on how to apply some properties.
So this should come as s by s square plus
Correct.
omega square.
Correct. Perfect. But I think students should be able to check these things.
Try out there.
Try out them.
Okay, so we have some set of basic transforms.
Yes.
There can be more. To start with, maybe this is
a
good set.
Correct. We'll keep adding to this.
To this list. Sure.